Now we're going to change things a little bit so we can talk about another concept. And so we're going to change the story to say that there's a bakery next to the playground, and Allison is in the habit of going there after we have our play date and buying things that she has for her family for the weekend. So she gets some extra utility from going to the playground because then she can go to the bakery as well. So nothing happens with my payoffs. These are the same as before. And if Allison doesn't go, she's also the same as before. But now she has a new benefit from going, which is the bakery. So if we both go, her payoff is 7, so it's 3 from meeting with us and 4 for the bakery. And then if she doesn't go, if she goes and I don't, it's 4, right? Because she's getting 4 units of utility from the bakery, and we've just added 4 to both of her payoffs from the previous game. So now we can again, we want to solve the game. We say, what should I do? And well, what I do depends on what Allison does. So what should Allison do? We can look for her best response, and we see that if I go, if we're in the top row, right, because I choose the row, she chooses the column, so in the top row, she could choose 0 by not going or 7 by going. She should go. Going is better than not going if I go. And in the bottom row, she can get 3 by not going and 4 by going. So going is better for her in this bottom row too. So if I don't go, it's better for her to go and get 4 instead of 3. And if I go, it's better for her to go and get 7 instead of 0. So these are her best responses. You can see they line up. It's the same choice no matter what. Going is better for her no matter what I do, and that's called a dominant strategy. Okay, so one choice or one action is better, meaning higher payoffs, regardless of what the other player does. So she really has a go-to strategy, right? It's a no-brainer. She should go because it's better for her to go no matter what I do. So she doesn't need to worry about think about what might Sarah do. She's just saying it totally makes sense for me to go. Now when I play, I have the same situations before. If she goes, so looking at this left-hand column, I should go. 3 is better than 0. If she doesn't go, I should not go because this 3 is better than that 0. But I can really count on her to go. Right? People are expected to play their dominant strategies. I mean, why wouldn't they? If they have one. Right, which they don't always. In the previous simple coordination game, neither of us had a dominant strategy, and that made it harder. We didn't know what to do. But now I can confidently predict Allison's going to go. I expect she's going to be there, and I can respond by going. And you can see that we now have only one Nash equilibrium, and that is going for both players. In this case, if she decides to go, I made the best response to that by going. If I decide to go, she made the best response by going. So we're both satisfied. Neither of us wants to change our own choice. Here, she's still okay with this. I didn't go, but she still made the best choice for herself, which was to go. But I'm not. I want to switch and say, look, if I knew she was going, or if I understood that she would be going, then I should have gone. I want to trade my 0 for a 3. And here, I'm okay with this. I've made my best response. So she didn't go, and I chose not to go. That was the best thing for me to do in that scenario. But she was like, well, if I knew Sarah wasn't going, I still should have gone. She wants to trade her So as long as one of us is wanting to change our own choice, it's not an equilibrium. And here we have an equilibrium where both of us are satisfied with our own choice, seeing what the other person did, we made the best response to that. So we're in equilibrium, we're stationary there, we don't have any motive to change anything that we've done. So that's the idea of dominant strategy. Let me know if you have questions.